Right, so we're talking about solving systems right now in our unit that we're covering. So here's a couple of questions that should look familiar, that we've done these type before. So we're going to solve this system by graphing. So the first one has a y-intercept of -3. So we're going to make a dot on the y-axis at -3. And then the slope is up 1/2. So up 1/2. Up 1/2. We do it a couple of times to give ourselves a little more room to find our solution and to get a good straight graph. So I'm going to go ahead and graph a line through these points. And look something like this. We want to kind of extend that in both directions. So, oops. Got to click on it just the right way to do that. So there's my line for the graph of the first equation. So now let's do the second equation. And we got to get we've got to rearrange this and solve this for y. So we're going to move the 5x to the other side of the equal sign, and we'll have 4y equals -5x plus 16. Then we're going to go through and divide everything by 4. And we've done this a few times this year, so this shouldn't be totally new to us. We just did it recently on a nice worksheet. So -5/4 x plus 4. All right, so to graph this one, we got to go up to 4 on our y-axis because of this 4 right here. And then we're going to go down 5 and over 4. So down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So there's my next dot right there. So now I'm going to graph this line, and it's going to look something like this. Come down like that, and we'll extend it in both directions to make sure it goes clear across the graph. So there we go, and you can see right there that it crosses at a very easy to identify location. So what would be the coordinates of that point? Well, it would just be 4, -1. So that has one solution. All right, moving along. Estimation is a quick way of knowing what your solution should look like or checking that your answer is correct. So we've kind of mentioned these three possibilities when it comes to systems of equations. So we know that if we have parallel lines, there's no solution. If we have two lines that cross in one spot like that, that's considered one solution. And if the two lines, when you graph them both, happen to be on top of each other like this, that's a situation which is called infinite solutions. Well, estimating solutions for systems of equations using inspection is kind of an important process. It helps us to go through this in a much smoother way. You can expect the slopes and the y-intercepts of the equations in the system to determine the number of solutions for the system. So that's kind of important. You can inspect the slopes and the y-intercepts and draw some really good conclusions. For example, we know that if there's one solution, there's one intersection at an x and y point. If there's no solution, those are parallel lines that never intersect. And if there is infinitely many solutions, they're the same line. So they have the same slope and the same y-intercept if you stop and think about it. So let's look at this. Here's a pair of equations, and if you graph them, they cross at one point, so that's considered to be one solution. If you look at their slopes, the slopes are different, and the y-intercepts are different. That means also another way to determine that the lines are going to have exactly one solution, and they're going to cross at one point. So kind of an interesting way to look at it. Now, I want you to understand these equations are not the equations that were used to graph these two lines. Otherwise, both of these slopes would be positive. Okay, now take a look at this. Here's a couple of lines that are parallel. So if you have two parallel lines right away, you can tell me that there's no solution. But you can also tell, if you just have the equations, by looking to see that the slopes are the same, but that the y-intercepts are different. That means that they're going to look like these parallel lines, but not cross in the same spot. So that means they never intersect, and so there would be no solution. Now in our third situation, you're going to get a couple of equations, and you're going to notice that even though they may be written a little bit differently, if you rearrange them and put them in slope-intercept form, you're going to have the same equation. So this could also be written as y equals 2x plus 2. So if they have the same slope, they both have a slope of 2, and they both have a y-intercept of 2, that means they're exactly the same equation, and so they have the same line, and they're going to have infinitely many solutions. Okay, so to find a solution for any system of linear equations by graphing, you just graph both equations and see where they cross, or see if one of these other situations comes up. So let's take a look at these. Without even graphing them, we can tell right now that we have the same slope, but we have a different y-intercept. So what would that look like? So you go up to positive 2, make a dot, and then you go up 1, 2, 3, 4, 1 over 1, make another dot. For the other one, we will go down negative 6, make our y-intercept, and then 1, 2, 3, 4. So there's our y-intercept and our first point that we used using the slope. So I'm going to go ahead and grab an arrow here and stretch it up through there. So there's our first graph. Here's our second graph. If you notice, we've got parallel lines. So that means they never intersect. And if they never intersect, there's no solution, right? So that's one type of situation that you'll encounter on today's assignment. Well, let's try a different one. You notice on these two, you actually have different slopes and different y-intercepts. So that means they're going to have one solution. So let's go up. On the first one, we have a y-intercept of 2. On the second one, we have a y-intercept of 4. So let's go back to the first one. We have to go up 1, 2, 3, and over 1. On the other one, we have to go up 5 and over 1, or down 1, 2, 3, 4, 5, and back 1, or back 1. So this one is going to come down through like this, and then this one's going to come through kind of like this, and you're going to see that they're going to cross somewhere here, and you will be able to determine that they have one solution. Okay, let's try one more here. Now, if you notice, these two have been rearranged, kind of like the ones we saw in an earlier example. This bottom one could be put in slope-intercept form, meaning we're going to put the x term right behind the equal sign, and the constant term will be the last thing that shows up. You'll notice that we have the exact same equation in each case. So if we were to graph it, starting at 2 on the y as the y-intercept, and go up 1, 2, 3, and over 1, or down 3 and back 1, down 3 and back 1, we're going to have a line that comes right up through there like that, and it's going to do it twice because both equations are the same. So in that case, you're going to have infinite solutions. All right, on this particular problem, the first one is not quite in slope-intercept form, so we're going to go ahead and write it in slope-intercept form. Y equals negative x minus 1. The bottom one we need to rearrange too, so that's going to be y equals negative 5x plus 3, and I didn't show a lot of the interim steps when I did that, but that's the correct solution there. So if you notice, slopes are different, y-intercepts are different. So there's going to be one solution here. So the first one, we start at -1 for our y-intercept, and the slope is a -1. So the first one's going to look something like this. And so it's going to go all the way up through both sides of our coordinate system, like that. Okay, the second one has a y-intercept of 3, so up to 1, 2, 3, and a slope of 5, so down 1, 2, 3, 4, 5 over 1. So it's going to come down like this, and you notice it crosses right there at that point, because this line's coming down through like this. So that point is easily identified as 1, -2. So it has one solution. Because these had a different slope and a different y-intercept, you can tell, one solution. All right, so you got an assignment on Canvas where you're going to be able to do the same thing, and then you're going to input your answers right on Canvas, so it'll tell you if they're right or wrong. And we've gone to great lengths to make sure that those answers can be input easily and understandably so that you can do a good job. Thank you very much.